All right, so writing this equation in slope-intercept form, we're going to take, first thing we're going to grab is that y-intercept. I know I'm going to use the equation y equals mx plus b. The b, my y-intercept, is going to be positive 1. I can pull that straight from the graph, and I'm going to look for another spot that I can count real nice to. You want to get a point like this one right here at 1, 4. This is real nice to count to, and I'm just going to count off my slope. So I'm going to go up 3 over 1. When I write out this equation, I've got my up 3 over 1, and then I already have my y-intercept right here of positive 1. The second one, in number 14, same issue. I'm going to start off with that plus 2, so I've got my y-intercept. Again, I'm going to grab those 2 points. I go down 2, so negative, down 2 over 1. My slope is going to be negative 2 over 1. And that's going to give me my second equation. This one. Standard form, I'm going to show you guys standard form on this one, and then I'm just going to do y equals on the next two because the test will be heavy on y equals and less so on standard form. But I want it to look like this, all whole numbers, x and y on the same side, no fractions, and x needs to be positive. I still have to get an equation to use, so I'm going to start off with that y minus y1 is equal to mx minus x1. Got to watch those negatives. Remember, when you're subtracting a negative, it's going to turn into a positive, and we need to make sure that those numbers all pull into the correct place. I'm going to distribute. You can either distribute this fraction, or since we don't want any fractions in the first place, I'm going to take and clear it by multiplying the entire equation by 3. Again, you're not going to have to do this tomorrow. I'm really just showing you what they're asking you to do. Just in case we're going to have standard form again. 3y plus 9 is equal to 6. I'm going to pull that 9 from both sides. I'm going to get negative x plus 3y is equal to negative 3. And then I'm going to divide by negative 1 to get my x to be a positive value. That's going to give me x minus 3y is equal to positive 3. And that's standard form. It's going to look like this. Tomorrow, I believe all you're going to have to do is pick them out of a lineup. We want it to look like that. I'm going to show you one more time, and then I'm going to go back to y equals. So this one, y minus y1, which is 3, is equal to mx minus negative 4. On this one, there are no fractions to worry about, so I'm just going to distribute my negative 2. I'm going to add my 2x to the other side. I got 2x plus y minus 3 is equal to negative 8, and then I'm going to add that 3 to the other side. And I'll get 2x plus y is equal to negative 5. And that's what standard form looks like. You're going to be looking for this kind of a look on your equations. Let's go on to that next page. Now it says standard form, but the quiz is going to be heavy on that y equals. So I'm going to show you slope-intercept form, as you will see significantly more of those kind of problems than you will standard form. Now, got to get that slope first for slope-intercept. I've got negative 6 minus negative 2 over 2 minus negative 2. It gives me negative 4 over 4. That's going to reduce down to negative 1. Since both of these values have negatives, I'm going to choose this to use in my y minus y1 equation. So I'll have y minus negative 2 is equal to negative 1. That's my mx minus negative 2. At this point, just solving for y. That's what you want to do. You want to get an equation, and then you want to solve it for y if you can. Moving things around, it's going to look just like that. This one, same thing. We got some negatives. We want to make sure that those negatives are properly taken care of. I'll have a 6 minus negative 6. Those are my y's. And I have a 4 minus negative 2. That's going to give me a 12 over 6. Reduces to 2 over 1. I'm going to leave it as a whole number because when I drop it into point slope right here, I'm going to use this point because there are no negatives. When I drop it into point slope, having it as a whole number makes my math just a little bit easier. I don't have to look at it as a fraction. Distribute that number first. Add the 6. And I'll get y is equal to 2x minus 2. Number 19. Write two lines that are parallel. Now, when you go for these parallel lines, all that has to be true for parallel lines is that their slopes are the same. So when I go, because remember it's y equals slope times x plus your y-intercept, when I go to put in that slope, they just have to be the same. So if I say, example, negative 7 over 4, you can choose any slope you want, gracious. Negative 7/4 is the one I chose. It just has to match. They are the same. Now, they're different lines. So if the slopes are going to be the same and we want them to be different lines, let's just make sure that they have different y-intercepts. So they're both falling kind of quickly, and this one starts at 5, this one starts at 2. So they're both going to look like this. They're just starting on different places on your y-axis. All right? Starting at different places on the y-axis. It's the slope being the same that makes them parallel. Perpendicular has got to be opposite slopes. If one's rising, the other's got to be falling. If one's going fast, the other one's got to go slow. So let's say this one's 1/3x plus 2. For it to be perpendicular, we need the reciprocal slope, the opposite reciprocal slope. So we've got, instead of positive 1/3, we're going to have negative 3/1. Your y-intercept, again, does not matter. I'm going to choose a different number just because. Then what I'm going to do, just move on to the next one. Write two equations that have the same y-intercept. We set up our equations. Y is equal to 3x plus 5. All they're asking us to do is keep that y-intercept the same. So I'm just going to, 1/5x plus 5. You'll notice I kept that y-intercept the same. You could have lots of different answers here. As long as your y-intercept's the same, you will be all right. My next one, write an equation of a line with a slope of this and an intercept of negative 5. I'm going to go straight to that y equals mx plus b form. My slope is 1/6. My intercept is negative 5. So it's just a straight drop into that equation. Could not get any easier than that. Last page. We want to get an equation, total cost. We've got this situation where we're going to a field trip to the Perot Museum. $150 for your group to show up, and they're going to ask for another $250 a person. So our cost, we have $150 for the guide. We also are going to be charged a per person fee of that much. Our equation is going to look like this. Notice my variable is attached to the fee that's going to change. It's $2.50 a person. We got to have that variable attached to the $250. Now we want to use the equation to determine the cost for 32 people. I'm going to take 2.5 times 32, and 2.5 times 32 is going to be 80. 150 plus 80. So it costs $150 to get in, and 32 people times 2.5 times $2.50 is $80. My total cost is going to be $230. Now, 25 has been giving my kids some trouble. Issue with 25. They're going to ask you for standard form. Now, if I were to just write this out, you're going to get a standard form. How much are you going to spend? You're going to spend $25 on your 25 cents on your apples a pound. You're going to spend $2 on your pears per pound. How much money you have to spend? You've got $8. Now, personally, I'm using inequality here, but don't worry about that. We're going to go equals, and it should be all right. Now, this is standard form. If I solve for y, that would be my slope-intercept form. So I subtract the 2.5x to the other side. We'll change it to 1/4. 2.5 same as 1/4. And then I'm going to divide everything by 2 to get my y by itself. So to get your slope-intercept form, you got to solve for y, and it's going to look something like that. Now, they're going to ask you for one possible combination. The easiest combination, I think, is to get all pairs. So if I have 0 apples, so a 0 in for there, how many pears could I buy? I could buy 4 pounds of pears. That is one possible combination. Another combination that would be easy to find, if I didn't buy any pears, and I've got $8 to spend on apples that are 1/4 a pound, I could buy 32 pounds of apples. Whoa, that's a lot of apples. But anyway, always go for that easy thing to use if they ask you when you have the choice. It's always better to get a correct answer than it is to try to be fancy and maybe miss it. Good luck on the test.